Welcome, everyone. Thank you for joining us today. My name is Carrie Grady-Vincent, and I'm the Senior Manager of Scientific and Clinical Programs at Osteoporosis Canada. I will be your moderator for today's webinar, The Benefits of Protein and Exercise, brought to you by Osteoporosis Canada in partnership with Think Beef. Before we begin, Osteoporosis Canada acknowledges the land that our offices, located in Toronto, are on is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. It is now home to many diverse First Nations, Inuit, and Métis. We also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. At Osteoporosis Canada, we educate Canadians about bone health, including healthcare professionals and their clients. We are the only national organization serving people who have or are at risk for osteoporosis. The organization works to educate, empower, and support individuals and communities in the risk reduction and treatment of osteoporosis. We are excited about today's presentation, which will provide general information about nutrition, exercise, bone health, and osteoporosis. It is not intended to provide individualized health advice. For more information, please consult your healthcare provider. If you have questions during the webinar, remember to click the question and answer button on your screen to submit your questions, and we'll try to get to as many as we can, time permitting. Before we begin, make sure you have your speakers turned up fully so that you can hear the presentation clearly. So now it is my pleasure to introduce our speaker today, Dr. Andrea Josse. Dr. Josse is an assistant professor in the School of Kinesiology and Health Science, Faculty of Health at York University here in Toronto. She is a nutritional scientist and exercise physiologist whose research area combines human nutrition and exercise science in the context of both human health promotion and chronic disease prevention. Her human research program focuses on different intervention strategies, including the provision of protein and micronutrient-rich dairy foods to achieve improvements in body composition, body weight, body health, and cardiometabolic outcomes. Dr. Josse has published 68 peer-reviewed papers, and her research program is supported by a variety of government and organization funding sources. She is highly committed to supporting trainee development in the areas of basic and applied human nutrition and exercise physiology. As such, she works closely with registered dietitians and personal trainers for all her research studies. So without further ado, please join me in welcoming Dr. Andrea Josse. Andrea?
Thank you very much, Carrie and Osteoporosis Canada, for inviting me to present this webinar today. I'm just going to share my screen. All right, so the title of the webinar is Protein and Exercise for Bone Health, Current Evidence and Recommendations. I'll start by sharing my disclosure slide. And here's a brief outline of what I'll be talking about today. So first of all, I'll start the presentation talking about our bones and osteoporosis, a brief overview and what is it. Then I'll talk about protein, so current recommendations for older adults, and are Canadians meeting the actual recommendations? And then I'll talk about some additional protein considerations, so animal versus plant, protein quality and digestibility, protein and bone health, and some current research. And then I'll finish the webinar talking about exercise, current recommendations for older adults, benefits of exercise for our bones, and protein nutrition to augment the benefit of exercise, so putting the two together. So I'll start with a brief overview of bone. So what is bone? Bone is approximately 50% mineral and 50% protein. So calcium and protein already we can see are very important for our bones. And what does bone do? Well, bone provides structure, shape, support, and strength to our body. It helps us to move along with our muscles pulling on our bones. It protects some of our organs like our heart and our lungs. And it is a major storage site for minerals, for example, calcium. So our bone mass changes across the lifespan. And you can see that from this figure over here. We have bone mass on the y-axis and age on the x-axis. So we accrue bone when we're younger, as you can see over here, and our skeleton grows until about the age of 20, 25. Then we plateau as we reach our peak bone mass. Then after that, we see a gradual loss of bone as we age. And females, as you can see here, have this characteristic dip around the age of 50, and this is indicative of menopause. And during this time, females can experience accelerated bone loss due to reductions in estrogen and other female hormones that are usually protective for our bone. As we get older, if our bones drop below a certain amount, then we may be at increased risk for osteoporosis. And females are at greater risk for osteoporosis compared to males. First of all, because we tend to reach a lower peak bone mass when we're young, and we have this greater drop as we age. And so, this contributes to a wider gap in bone mineral density between the sexes in older age. And that's why we see more females getting osteoporosis, or at least one of the reasons why we see more females getting osteoporosis than males. Our lifestyle can affect our bone health. So in 2016, the National Osteoporosis Foundation published a position statement on peak bone mass development and lifestyle factors. So that is that diet and exercise does have an influence on our ability to reach our peak bone mass, but also in our ability to stave off bone loss as we age. And in this position statement, they said that diet and exercise can influence upwards to 40% of our attainment of peak bone mass. That's quite a lot. So what is osteoporosis? Well, essentially, it's literally porous bone. Okay, so loss of bone mass, bones become porous, and compromised bone strength is a key feature of osteoporosis because this increased fracture risk. So you can see on this slide, I put some pictures of osteoporotic bone, and you can see these bones compared to normal bone are much more porous than what the normal bone matrix would be. The holes are larger. And if you look over at this picture over here, you can see a really large hole in the bone. And you can understand that this bone here would fracture much more readily than this bone would. Osteoporosis is sometimes called a silent disease until the age of 50 or 60 years old. And symptoms of osteoporosis include pain, potentially pain in your back or pain in your hip, loss of height or kyphosis, so a hump over here because of compression fractures in our vertebrae. And a key hallmark of osteoporosis are these fragility fractures, so these non-traumatic fractures. So for example, when you fall from a standing position, it's not traumatic like you could fracture in a car crash, but a fall like that could cause a fracture in someone with osteoporosis. Now, osteoporosis affects spongy bone or trabecular bone more so than cortical bone. And this is seen in the major fracture sites of osteoporosis because they contain more of the spongy bone than cortical bone. So the main fracture sites are the wrist, the distal radius, the hip or the femoral neck, and the spine. So these vertebral bodies. And in terms of diagnosis of osteoporosis, it's generally diagnosed with a DEXA scan, and you can see some pictures of DEXA scans here on this slide. We have a lumbar spine DEXA and a femoral neck DEXA, and you assess risk of osteoporosis by comparing the bone mineral density of a particular person to reference ranges, and you decide if you're above or below a certain amount in a particular reference range, and that's indicative of osteoporosis. So given that osteoporosis is associated with pain and debilitating fractures in areas like the spine and the hip, it can also greatly affect our mobility, our functional capacity, and our activities of daily living. So that is our ability to do things like carry a grocery basket or gardening or reaching up high for something or climbing the stairs or housework, exercise. And so therefore, this affects our quality of life. And A main goal of ours should be to decrease our risk of osteoporosis and live a high quality life free from pain. So how can we prevent osteoporosis? Of course, this is a loaded question, but for this webinar, I'll just mention a few key factors. There are two key factors to think about. First of all, we want to achieve a higher peak bone mass when we're younger. So make this trajectory as high as possible. And we want to prevent the loss as we age. So make these trajectories as shallow as possible. And how do we do that? What do we have control over? Well, we primarily have control over our nutrition and our physical activity and exercise. And this is what the webinar today will focus on. With respect to nutrition, calcium, vitamin D, and protein are of most importance. And physical activity, aerobics, strength training, resistance exercise, balance exercises. These ones are most important for osteoporosis. And I put a little asterisk over here just to denote that, it's important to understand that we aren't fully in control in this regard, because our genetics plays a huge role. So we got to choose our parents properly. Our sex, so whether we're male or female, and this relates to our hormone fluxes throughout our life. When we undergo puberty, and for females, when menopause happens. So all of these factors play a role in our bone mineral density over time. So we don't always have full control, but again, these are some things that we can control in certain respects. Okay, so we'll move on to the second section of the webinar, which is about protein. So I'll start off this section with a general discussion about the current protein recommendations in Canada. So first we have the Canada's Food Guide, and there's a picture of the snapshot that I have here on the slide. It's consisted of 3 food groupings in relative proportions. And this Canada's Food Guide is new-ish. It came out in 2019, and it replaced the old food guide, which was more prescriptive in nature. So it had the serving sizes and the food groups and things like that. So this is what our new food guide is. And a quarter of the plate is protein foods. Okay, so I've highlighted this. Half of the plate is fruits and vegetables, a quarter is grain products, and a quarter is protein. And this is what we call our food-based dietary guidelines. Our Canada's Food Guide is flexible, it's simple, and it provides general advice on healthy eating. And it also supports different eating patterns consistent with what Health Canada believes is a healthy diet. So for example, if you are someone who eats a Mediterranean style diet, a vegan or vegetarian diet, a flexitarian diet, just a general omnivorous diet, this food guide is still relevant to you, and you can see your own eating patterns within it, which is good. As I mentioned before, it's not prescriptive, so it's not going to tell us have 3 servings of meat products and 3 servings of dairy, etc. It doesn't have that granularity. But it is quite similar to the US MyPlate. So I've shown a picture here of the MyPlate, with half of the plate is fruits and vegetables, a quarter grains, and a quarter protein, and their drink of choice is dairy. Next, we have our dietary reference intakes. So these are our DRIs, and they are the same for both Canada and the US, so they're harmonized together. And this is what we call our nutrient-based recommendations. So these recommendations let us know how much of a particular nutrient, so not a food, we're talking nutrients at this point. So calcium, protein, iron, zinc, etc. So how much of each of those should we consume based on our age and our sex? The 2 that I will discuss in relation to protein are the recommended dietary allowance, or the RDA, and the acceptable macronutrient distribution range, or the AMDR. So what is the RDA? You may have heard about the RDA in the past, but this is the minimum daily average intake to meet the needs of most of the population. So this is done statistically from experimental data. And so it meets the needs of most of the healthy population, but the key is to understand that the RDA is set to prevent disease. It's not the amount necessarily needed to achieve optimal health. The amount needed to achieve that is higher than what is needed to prevent disease. And I think we can understand that. the acceptable macronutrient distribution range is the recommended percent of energy range of a particular macronutrient. So what percentage of our daily calories should come from a specific macronutrient, of which there's protein, carbohydrates, and fat. So these are our DRIs for protein. The RDA, there's 3 of them in particular, and they're separated by age. You can see the younger ages have a bit of a higher protein recommendation because we're growing, and so we require more protein in that regard. But from 19 years and older, so all adults, our protein recommendation is the same. And this is a relative recommendation based on our body weight. So it's 0.8 grams per kilo per day. And then here's the AMDR, the macronutrient distribution range. So we can consume protein anywhere to make up 10% of our daily energy, all the way up to 35%. And so this is consistent with, if individuals want to consume a higher protein diet, this is probably within the AMDR as well. So how do we figure out how much protein you particularly need? Well, this is how we do the calculation. So you figure out your body weight in kilograms, okay? And I just put, just as an example, 60 kilogram female, age 55 years. So this individual would use this particular RDA, the 0.8 grams per kilo. So you take the body weight, multiply it by 0.8, and you end up with a protein amount, so 48 grams per day. So this particular person, according to the RDA, requires 48 grams of protein per day. So to help us figure out what we should eat, I created this table of common protein foods from both animal and plant sources, and it's adapted from some sources that I listed below. It has serving sizes that are equated to 100 grams, and I think this is good from a comparison perspective. I also have the protein amount within the 100 gram serving and the energy that it provides. So if we take the 48 grams per day of protein that this person is to consume based on the RDA, I've just done some quick calculations using this table with animal sources above and plant sources below. I've done some calculations to figure out what their daily protein food intake should look like. So they may start breakfast with 2 eggs, which provides 12 grams of protein. Then they may have a tablespoon of peanut butter on their sandwich for lunch. Whole grain bread would provide additional protein. 1 ounce of almonds as a snack, which provides 6 grams of protein. And then a 3-ounce steak, which would provide 26 grams of protein for dinner. So overall, this person, if they ate this way, would be able to achieve their protein recommendation. And so this is how we can use this particular table. But let's take a little closer look at some of the information on the table. When we're choosing protein foods, like what I've done here, we must consider the protein content of the food, the serving size, and the energy content. And this is dictated by, your individual goals and how, what you require in terms of your intakes. So if we choose 3, I've chosen flank steak, tofu, and almonds as an example. Let's look at beef versus tofu. All right, a vegetable source of protein versus the animal source. So in 100 grams, beef provides 30 grams of protein and 230 calories. For tofu, the same quantity provides less protein, so 9 grams of protein and 70 calories. So you can see that you would need to consume 3 times the amount of tofu to get, to equal close to the amount of protein in the flank steak. And same with the calories. The calories would triple, which would be around the same over here. So this is just, an example looking at the protein content. Usually plant sources are lower in protein content compared to animal sources, but they also have other types of nutrients that one may be interested in. Another example is looking at almonds over here. So almonds in 100 grams contain 21 grams of protein, which is a really good amount. But they also contain 600 calories in 100 grams. And most people don't consume 100 grams of almonds. Most people would consume maybe 1 ounce of almonds, which is 28 to 30 grams, which I've put in here as a snack, provides about 6 grams of protein. So, we also have to consider the calorie content of the protein foods and whether that jives with what our goals are. Another big consideration is the quality of the protein, and I'll get to this in the next couple slides. So in terms of quality, there's considerations. Does a certain food provide all the essential building blocks or amino acids in adequate quantities to support protein synthesis? And if yes, then this particular protein food is considered to be of higher quality. I've listed here a table of the amino acids, which make up all of the proteins that we eat and the proteins in our body. And there's 9 essential ones. So these ones we need to get from our diet. We can't synthesize them in our body. So that's why they're called essential. So we need to eat protein foods that contain these particular amino acids such that our bodies can have good quality protein synthesis. So again, the protein quality considerations, the content and the amount of amino acids within a food, with plant sources being less sometimes. The amino acid complement, so the amount of these essentials that are in the actual food, and digestibility is something else I haven't really talked about. But the digestibility of a protein food refers to the ability of our body to break down the food and absorb the amino acids within it. And when we talk about amino acid complement, there's this notion of limiting amino acids. So what is a limiting amino acid? Well, it's one that is supplied in less than the amount needed for protein synthesis. And so in some protein foods, they contain not enough of a particular amino acid to sustain protein synthesis. And this could be a problem in some plant sources. So for example, lysine is limiting in grains and methionine is limited in legumes. So for some of those reasons, we tend to say that plant proteins are of lower quality than animal proteins. And I've listed these out here. Again, these are the main reasons that we talked about. So they contain less amino acids. They have a greater impact of these limiting amino acids, so they don't have a full complement. And they tend to be more poorly digested than animal protein sources because of the presence of some of these anti-nutrients. So phytates, oxalates, fiber, these are things that impede the absorption of certain nutrients, and they're found inherent in the plant foods. However, there's good news. It's not all doom and gloom for sure. Pairing plant proteins together does improve the quality of the plant protein meal that you're consuming. And this is a practice called protein complementation, which I'm sure if individuals are vegan or vegetarian, they're quite familiar with. So let's look at rice and beans, for example. This is a common staple food in certain parts of the world. Excuse me, Mexico, South America, Africa, etc. And perhaps it's no coincidence that these plant foods are eaten together, because when they provide a full complement of amino acids despite their limiting amino acids. So rice is limited in lysine and beans is limited in methionine, but when you put the two together, you get a full complement. And so rice and beans has been sustaining populations around the world for a very long time. And here's some other complementary plant protein dishes like corn and beans, as well as chickpeas or hummus and whole grain bread. So I just want to also say that vegetarians and vegans can absolutely consume enough protein to thrive. I want to make that point. Planning is required. And, if you do planning and complementary proteins and the levels of proteins in particular foods, then I would say the protein quality is not really an issue, but it does take some planning. So what else can we do to improve the quality of plant proteins? Well, there is a recent paper published in 2022 addressing just that. So we know some of the issues, as I mentioned, with plant proteins. They have a lower digestibility, a lower protein content, and limiting amino acids. But to improve digestibility, there are certain things we can do, like we can soak the beans, we can germinate them, we can cook them, which makes them softer and renders their amino acids more available. There's industrial processing of soy foods into tofu and other such factors. We can use probiotics and enzymes to start the digestion process. We can, do additional fermentation, soaking, dehulling, etc. So there's several things we can do to improve the yield of protein from these foods. And then some of these other ones we've talked about already, or we will talk about soon. Like, for example, we'll talk about protein isolate consumption. and fortification. So are Canadians eating enough protein? We've learned about protein requirements and protein quality, but the question is, are we actually consuming enough to support our health? So here we can see, according to the Canadian Community Health Survey, which is a national nutrition survey that was put forth by Health Canada, we can see that as a percentage of total calories, so our acceptable macronutrient distribution range, which I've drawn here in red, we're consuming about 16% of our daily energy from protein. So yeah, we are consuming enough in that regard. And as a relative amount, so according to the RDA, it seems like we are as well, which of course, with younger males consuming quite a fair bit of protein. So remember, the RDA is 0.8, and here we can see that most Canadians on average are consuming above that. But I just want to make a note that the highest proportion of adults consuming inadequate intakes, so those less than the RDA of protein, were females in this particular age group. And that's alarming, because this is also the age group that is at increased risk for osteoporosis, or that seem to have a greater issue with osteoporosis. So what are Canadians eating? Well, according to the CCHS, again, we get 64% of our protein from animal-based sources, so dairy, poultry and eggs, red and processed meats, and fish and shellfish. And then the remainder comes from nuts, seeds and legumes, vegetables and fruits, and cereals and grains. And there's a miscellaneous section over there. So according to the CCHS, so I just showed you, we may be on average consuming enough protein in accordance with the RDA. But the question that I have is, is the RDA sufficient enough to support musculoskeletal health in older adults? Remember, the RDA is not designed to promote optimal intakes. It's there to promote or to make sure that individuals are not deficient. So in 2013, the protei study group, which is an international expert advisory group, came out with a position paper in which they said older adults greater than 65 years need more dietary protein than younger adults to support good health, promote recovery from illness, and maintain functionality. So they believe that the RDA is potentially insufficient for these particular factors in older adults. And some important points from this particular paper, where they synthesize and look through all the evidence in older people, they said that older people should consume an average daily intake of 1 to 2 grams per kilo per day. And if exercising, this amount should be even more, around 1.5. So this is much higher than the RDA. The per meal protein intake should be around 25 to 30 grams per meal. And protein source, timing, amino acid supplementation, et cetera, should be considered in some cases. But of course, more research is needed with better studies and methodologies. And I also wanted to point out that there was a similar consensus paper that was published in 2014 from the European Society for Clinical Nutrition and Metabolism, and they came up with some very similar numbers. So it seems to be something to keep note of in terms of older adults requiring, or the recommendation for older adults would be to consume more protein. I also just want to mention that these studies were done in relation to lean mass and muscle and functional capacity and strength. So their outcomes were not bone specific. However, well, I just want to also say that we do know much less about recommendations for bone, and we do know a lot more about that for muscle. So what about the protein recommendations for bone? As I said before, the previous slide shows the recommendations for muscle and strength, et cetera. But I would say that they likely also correspond to bone, given the interconnectedness of the two systems, the musculoskeletal system, and how they depend on one another. So what we find for muscle is probably suitable for bone. And so there was an expert consensus review published in 2018 by René Rizzoli and colleagues, and he's in Switzerland. And they looked at the benefits and safety of dietary protein for bone health. They concluded that dietary protein above the RDA may be beneficial for bones. So some indication that higher protein levels would be beneficial. And in this particular review, they highlighted some main findings. For example, hip fracture risk is modestly decreased with higher dietary protein intakes, and there's several studies that show this to be the case. And this is provided that calcium intakes are adequate. So you need to have the adequate level of the micronutrient. Bone mineral density appears to be positively associated with dietary protein intakes. So the higher your level of protein that you're consuming, the higher your bone mineral density, and vice versa. The lower the protein, the lower your BMD. And protein and calcium combined in dairy products has beneficial effects on our bone. And this is likely related to the fact that dairy products contain calcium, protein, vitamin D all together in one package. So the benefits of dietary protein on bone outcomes seem to require adequate calcium intakes. And this is, something specific to bone, not necessarily related to muscle. Now, I don't have time, unfortunately, in the webinar to go through all the studies that they cite. And just to mention too, that a lot of them are observational in nature, in that they looked at people's diets and they looked at their DEXA scans and they looked at relationships between the two. But this is really the best that we have for bone health. So some key takeaways relating to protein. Protein is beneficial for bone health across the lifespan. Intakes higher than the RDA in older adults are beneficial for fracture risk and bone mineral density. These consensus statements indicated that intakes of around 1.2 grams per kilo per day should be recommended, and more if exercising. But I just want to also mention that, the current guidelines, the RDA is still 0.8 grams per kilo per day. This has not officially changed, but given what I've shown you today, there seems to be mounting evidence in favor of a potential change of the RDA, particularly for older adults, because they have additional considerations in terms of maintaining health. The food source of protein may be important to consider. So this is insofar as protein quality, quantity, calories, and micronutrients are concerned. So thinking about all these things when one chooses a protein food to consume. Whole food animal sources may offer some more benefit, like dairy products as an example, because they have higher quality protein and are accompanied by these minerals and vitamins in adequate quantities to help our bones. But I want to also mention that plant sources can also be adequate with additional consumption considerations like we talked about. According to the Canadian Community Health Survey, we are consuming adequate levels of protein. Older adult females are most at risk for protein deficiency and malnutrition. And so this also begs the question for me around the RDA. Is it still the right adequacy benchmark? If we raise the RDA, then we'll see that most, on average, women in that category most of them would be deficient. And again, more research is needed to assess the effects of protein on bone in long-term RCTs. And we don't have a lot of long-term RCTs, or many that I know of, but these are difficult to do. Okay, section 3, exercise for our bones. So aging muscle and bone responds well to exercise. Exercise is good for our muscles and bones as we get older. Improvements in physical function and strength, lean body mass, and balance are some of what we see in relation to exercise. Resistance exercise is a major stimulus for protein synthesis, lean mass, and strength gains. Impact and weight-bearing exercises are also really great to help stimulate our bones. And this can help improve bone mineral density, but at least if it doesn't do that, then it can help decrease bone mineral density loss. And intensity matters. So relative intensity being higher is of importance to our bones, because moderate continuous exercise may not necessarily provide an adequate stimulus than high intensity exercise for our bones. And again, this is relative. A systematic review and meta-analysis published in 2020, looking at 22 randomized controlled trials in older adults greater than 75 years, showed that resistance exercise significantly benefits muscle hypertrophy and strength. And I have the reference there for you to look at. And also along the same lines, resistance exercise and weight-bearing exercise, we've shown that it does benefit older adults that are at higher risk for fractures, falls, and frailty. And it may even benefit those that have already fractured. So adding in some resistance and weight-bearing exercises into our regimen would be important to help with osteoporosis. And particularly for fall prevention, this is a really key factor in exercise for osteoporosis. Training of balance, functional tasks, coordination, or gait patterns, as you can see some of these activities here, it really helps with fall prevention. So what is actually recommended in Canada with respect to exercise for older adults? Well, the Canadian Society for Exercise Physiology recently published their 24-hour movement guidelines for adults greater than 65 years. So I've highlighted here basically what their physical activity recommendations are. So 150 minutes per week of moderate to vigorous aerobic activity. Muscle strengthening exercises are really important. Light physical activity, like walking around, doing some gardening, things like that, walking around the house, housework, and physical activity that challenge balance. And so they also go on to say that being active for this amount of time helps to reduce chronic disease risk and maintain functional independence, mobility, fitness, improves body weight, maintains our bone health and our mental health. So they also acknowledge in the CSEP guidelines the importance of physical activity for our bones. So in terms of Osteoporosis Canada recommendations, exercise is recommended for people with osteoporosis to improve their bone health and prevent bone loss, falls, and fractures. And in 2014-15, Osteoporosis Canada, in conjunction with researchers at Waterloo and the government, they published expert consensus guidelines for exercise with osteoporosis. And so they recommend a multi-component exercise program that they called Too Fit to Fall or Fracture. And this component, here's an infographic about it here, but it contains information about strength training, balance exercises, postural awareness exercises, and aerobic physical activity. And these recommendations are in line with CSEP's recommendations, as I showed you before, but they do contain additional details regarding exercise adaptations for those with osteoporosis. So maybe, you have an issue with standing up or something in relation to a particular muscle or bone area. And so there's certain exercises and adaptations that you can do to still receive the benefits of exercise, but do it in a safe way. Recently, Osteoporosis Canada created BoneFit, and this was done in conjunction with various experts in the field. And it's a training workshop for healthcare providers and exercise practitioners. And it's for people to learn more about exercise, safe practices for exercise in people with osteoporosis. It is definitely a great resource for these individuals, but also for the community when you're looking for a professional to help you with an exercise program, if you're someone that requires that. So if you go to the BoneFit website, and here's the link over here, on the website, you can put in some information and look for an individual that has this particular BoneFit training, as this person would understand and create an exercise program that would be most benefit to you as someone that has osteoporosis or is at increased risk for osteoporosis or even has questions in that regard. So I encourage you to look that up. Okay, the last section, section 3B, combining protein and exercise. So generally speaking, protein augments the anabolic effect of exercise. And in terms of the role that protein plays, well, it can stimulate protein synthesis when it's consumed. It improves exercise training adaptations. It can facilitate exercise recovery. It can help us to gain strength. and it does promote physical function. But I also want to mention that, this role of protein is likely a small one in comparison to what exercise or resistance exercise can do for our body and for our bones. But nonetheless, it still plays a role, and we should be thinking about protein nutrition during the day to maximize our exercise adaptations. So if you exercise, you likely require more protein. And this is a pretty wide range, but essentially it is greater than the RDA and upwards of maybe 1.5 grams per kilo per day. And this is what the evidence shows. But there are certainly other factors that we can think about. So aging and physiology and how that affects protein, timing of ingestion, distribution throughout the day, et cetera, the type of protein to ingest, and whole foods versus supplements. So this is where I'm going for the remainder of the presentation. So in terms of aging and physiological differences between younger and older people, older adults may develop resistance to the positive effects of dietary protein on the synthesis of protein. And this is something called anabolic resistance. And you may have heard of this before, but in case you haven't, in other words, older adults need more protein to maximally stimulate muscle protein synthesis with exercise. So, we're not as sensitive, if you will, to the effects of protein. So we need a little bit more to achieve the effects. And anabolic resistance, as you can see here, is just one of the reasons, of which there are several, for why older adults may need higher protein intakes for health. And I've listed a couple of them over here. So this is a physiological reason why older adults need more protein, and it's backed up by science. I put some of the references down here for you to look at. In terms of timing of protein intake, well, people tend to eat a Western style eating pattern. And so this is characteristic of an uneven protein distribution. So you may have tea and toast for breakfast, followed by a salad, then followed by a large steak at dinner time, for example. But this paradigm of protein intake is problematic because we end up spending most of our day in negative protein balance. And then when we consume one big bolus of protein at the end of the day, our bodies can't use all of it effectively. So it essentially, the amino acids or the protein could be wasteful for our bodies. So what we need to do is focus on a more even distribution of protein throughout meals and snacks. And so what I've done here is I've listed 2 higher protein breakfasts, 2 higher protein lunches, and 2 higher protein dinners. And the idea is to consume protein at every meal throughout the day, and with snacks in between, not as big as meals, of course, but the snack should also contain some protein. And so what we're doing with this strategy is that we're constantly supplying amino acids or protein to the body to support musculoskeletal health. And so some of the guidelines or the recommendations from literature that we talked about was around 20 to 30 grams per meal, 0.3 to 0.4 grams per kilo per meal. So this is the relative amount. And this type of feeding is called pulse protein feeding. So when we eat one meal, our protein synthesis goes up, and then we use the amino acids that we take in, and then it drops back down. And then you hit it again, and it goes back up with the next meal, and then it drops back down. And then you eat another meal, and it goes back up. So you don't let it drop too far down. And so this is over the day, you can consume protein this way. What about around exercise? So I usually get this question about post-exercise protein, and it is likely beneficial as a strategy as well if you want to focus on that, because what we're doing at that point is after you've exercised, your muscles are hot, your muscles have blood flow diverted to them, and so we're supplying the body with amino acids when the muscle is most ready to use them, or muscle and bone really at that point. And so it improves nutrient delivery to the muscle if we consume it after exercise. But I challenge you in your thinking, because I wonder if it's actually necessary as a focus to focus particularly on post-exercise feeding. If you think about it, if you spread your meals out throughout the day and have 3 higher protein meals or sufficient protein meals along with snacks, you're going to hit that pre and post exercise window. You're going to be consuming protein around the time that you exercise. So it may be more beneficial and less of a burden to really just think about spreading your protein over throughout the day. Type of protein to support exercise. So in terms of some additional guidance around meals and snacks to support exercise adaptations, particularly, we want to focus on consuming essential amino acids. So these are the ones that our bodies can't make. We need to get them from foods. And in particular, we need to focus on consuming leucine. So around 3 grams of leucine per meal. And leucine is a particular essential amino acid that is important because it preferentially stimulates muscle protein synthesis. It's like the amino acid that has the ability to turn on the switch and get the machinery going to build more protein. So it is a really important amino acid to keep our eye on in this regard. Of course, there are additional considerations regarding plant protein, and I just put this in here to jog our memories. We have to think about some of these factors when we're choosing protein foods to support our exercise program. But if we look at this table over here, they have animal and plant sources. We have, again, foods with the same amount, so 100 grams, total protein in them, essentials, and leucine. And we can see here that plant sources have less leucine and less protein than animal sources. So this is no different, again, than what we had talked about before. So animal sources tend to contain higher levels of leucine and essential amino acids. But if we look at the first 3, so whey, soy, and rice protein concentrate, these are isolated protein sources. And so it's not surprising, plant or animal, that they contain the most essentials and leucine. And you don't need nearly 100 grams of these protein sources to get an adequate amount of leucine or essentials. So these are considered protein supplements. So we're able to get a more concentrated amount of the protein within them. So this brings me to the last slide of the presentation before my summary. I'm going to talk a little bit about protein supplements. So I'm personally an advocate of taking a food-first approach, so trying to get the protein and nutrients from food sources. I like to eat food, so I like to get my protein from food. And, you know, I believe Osteoporosis Canada also has the same approach, and so has most of the dietitians that I've met. They all talk about a food-first approach, but we also understand that protein supplements provides an easier way to meet protein needs for some people, and they do have great utility. So people like vegans and vegetarians may benefit from plant-based protein isolates. Those with chronic disease who need more protein to heal and get better and who need more nutrition would benefit from protein supplementation. Individuals that are bedridden because they're weak or they had a surgery recently, etc., they're sick, they would benefit from protein supplementation. And maybe individuals with additional limitations, like those that may have dentition limitations or cognitive limitations, etc., they may also benefit from consuming some additional protein. So in terms of these plant-based protein supplements and isolates, so for example, soy, pea, potato, rice, these have all been studied in various capacities in the literature in randomized controlled trials, and they've shown to be similar to animal-based supplements in that they stimulate muscle protein synthesis well following exercise. And most of this research that I've seen is in younger individuals. And here's a paper that shows this over here. Protein amount and content, just as a reminder that in plant-based whole foods, it tends to be lower, like I've shown you several times, but there's obviously much less of a difference when you look at plant-based protein isolates and powders than when you look at the food. So again, this may be of utility for individuals who want to consume a plant-based diet. They may want to use protein supplementation. So in summary, here are my key takeaways regarding exercise and protein. So aging muscle and bone responds well to exercise. So resistance exercise, impact and weight-bearing exercise seem to be more preferentially important for our bones, and it's shown to improve, and balance exercise, I should say, is shown to improve physical function, strength, lean body mass. Resistance and balance exercises, as I just said, specifically help to prevent falls, fractures, and sarcopenia in those that are at risk. So increased protein intakes, potentially above the RDA, have been shown to support beneficial exercise-related adaptations to musculoskeletal health. So again, it's something to think about in regards to optimizing health versus staving off disease, which is what the RDA is set for. Protein timing is less of an issue if protein intakes are spread out well throughout the day. But as I said, it won't hurt to consume a protein-rich snack post-exercise. That's not to say that, you know, after you finish your last rep and set on the exercise machine, you run to the locker room and down your protein shake. That's not a necessary practice, in my opinion, but definitely consuming some protein within the hour and a half or so after your exercise bout would be a good strategy, and perhaps before as well. But again, spreading it out throughout the day is a good place to start. Animal and plant protein foods may be equally effective for strength and lean mass gains. And this is assuming adequate amounts of essentials and leucine are consumed. So looking back at those particular amounts that I said, the goals to hit particular levels of leucine and essentials. And so this is where some supplements for the plant protein sources may be useful. You don't need supplements per se, but if you do the math, you'll realize that a lot more protein foods need to be consumed otherwise. But in terms of supplement studies, they've shown this to be the case, that they're equally effective with potato, protein isolate, soy, pea, corn, beans, peanuts, rice, oats. There's a lot of research out there showing that. But with that said, I think more research is still needed in older adults. And I think there are still other plant-based protein sources that we could look at. So like these ancient grains or these pseudo cereals, quinoa, for example, is a higher protein plant-based grain, which would be interesting to assess. So with that, that concludes the presentation. I'd like to thank you very much for listening, and I'd be happy to take any questions that you may have. Thank you.
Thanks, Andrea. That was absolutely terrific. So much information for us to think about.
I don't know if there's time.
We have some time.
Okay.
We've got some great questions ahead. There's lots of great questions coming in, but we're not going to be able to get to all of them. So I'm trying to summarize some of them.
Sure.
So let's start with this one. I'm finding it difficult to eat adequate amount of protein at each meal. Any advice?
Right. So yes, that is a really great question. And I know this is something that a lot of people do struggle with. And so the first thing I would say is that planning your protein is essential in the day. So, you know, we looked at those tables that I provided. There's lots more information on the internet regarding the amount of protein in particular foods. And so if you know, based on the RDA, the amount of protein you're supposed to consume in a day, we can work backwards, maybe with a dietitian or somebody that is an expert in this area. They can work backwards and try and plan for the amount of protein that you require. Keeping in mind that maybe you want to go even above the RDA, given the latest research. So I think that it is a difficult thing to do, absolutely, but there's information out there to help people to plan. And perhaps you may consider having one of your meals or one of your snacks with a protein supplement, be it whey protein or like an animal-based protein or a plant-based protein. If you're really having trouble, then having one of your protein meals or snacks to be supplementation would allow you to push the amount of protein that you can consume in a day.
Okay, thank you. Next question. With proper exercise and diet, is it possible to improve bone density post-menopause?
Okay, so this is a really great question. I'm glad somebody did ask this. And so, you know, I did summarize a little bit of the literature in this regard, but the truth is I think that diet and exercise is really important to focus on with respect to maintaining our bone health over the lifespan. And once we get into the postmenopausal time frame, we're really focused on decreasing the losses as much as possible. Like, we know that we do lose some bone as we age, and perhaps diet and exercise may need to be augmented by other factors like medication and other such things. But, you know, we do see that diet and exercise provides a modest benefit or a modest effect. And you know, it may not be that you can increase your bone mineral density in postmenopause, but you can certainly decrease losses, you can decrease fracture risk, and you can increase your strength and improve your balance, et cetera, and decrease your risk for falling with exercise and diet. And there's really good data out there to show that that is the case. Now, we don't have many RCTs, the level of evidence we would maybe want in this regard. But I do think that there's absolutely a place for diet and exercise to help here, primarily in regards to preventing falls and fractures.
Okay, that's great. Is there a time of day that it's better to exercise?
I would say that generally I'd be really happy if people exercise at all. So for me, an initial focus would be just to get people doing some exercise at a time that fits into their schedule well. That would be the first thing that I would look at. So, you know, if someone came to me and wanted to start an exercise program, I would ask them when they feel they can fit it in to their exercise, to their day. I am not sure of much research showing that one particular time of day is better than the other, but I think it's just how you could incorporate exercise into your diet, into your day, and then how diet could fit around that to augment your exercise gains with protein. So in short, I really don't know if there's a particular time of day that's better, but it's the time of day that works better for you.
Okay.
Personal preference, I would say.
Okay, we really only have time for one more question.
Sure.
So the question is, does riding a bike count for anything?
Yes. Okay, so yes, good question. And again, doing any exercise is better than doing no exercise at all. Riding a bike is certainly beneficial for other factors. Maybe not as much for bone per se, depending on the intensity of the bike ride. So I did talk about higher intensity exercise being beneficial, and you can certainly do higher intensity exercise or intervals with a bike. And so I would suggest if you were going to bike, with it being a low impact type of exercise, so you don't get the particular impacts that you would from jumping, let's say, making sure that the cycling is of higher impact relatively, or incorporate some intervals would be a good place to start with cycling for our bones. Now, remember, cycling is a form of exercise, so it is going to be beneficial for our muscles. It's going to be good for our cardiovascular system, et cetera. So all of these things also fit together in respect to improving musculoskeletal health. So I do think that biking is a good type of exercise to do. Is it most beneficial for bones? Not necessarily, but we can increase the intensity of it such that the muscles pull on the bones and we get that sort of stimulus. So it is useful if you do it that way.
Great. Well, that concludes our webinar for today. I would like to thank again Dr. Josse for such an informative presentation on protein and exercise. And also I want to thank our partner, Think Beef. For more information on osteoporosis, please visit our website at osteoporosis.ca. our website. It includes many tools, including a calcium calculator, podcasts, quizzes, and a repository of our past webinars, including many, as you can see here on the screen, on different forms of exercise. And again, thanks for joining us today. Thanks again to Think Beef, and wishing you a wonderful day. See you soon.